write the first derivative of the function ln x to the 8th over x squared, and then it asks us where would f of x have horizontal tangents. I'd use quotient rule for this. You've got a fraction of two functions that you're taking the derivative of, so we can use this idea of quotient rule. So we'll do the derivative of the top function times the original of the bottom function. Then we'll take the derivative of the bottom function times the original top function, and then divide by the bottom function squared. Now for this is going to be a chain rule itself, where if it was just x to the 8th, then we'd say the derivative would be 8x to the 7th. But the inner function here is not just x, but it's ln x. So first we leave that part alone, and then on the outside we multiply by the derivative of ln x, which here would be 1 over x. If you're doing this derivative is like you have a g to the 8th that you're taking a derivative of. You see here, g takes the place of the ln x. So the derivative of g to the 8th would be 8g to the 7th, but then times the derivative of g. So here we have to do 8 times g to the 7th, but times the derivative of the inside, which is 1 over x. So then we'll leave the x squared as is. Here, derivative of x squared is 2x. And then we'll have that all over x to the 4th. Could simplify a little bit, but not too much. This will become 8x ln x to the 7th minus 2x ln x to the 8th over x to the 4th. Now that's the derivative function, and they want to know when does the original function here have horizontal tangents. So we need to set the derivative equal to 0 to find those locations. Alright, so when the derivative is 0, that's really dependent on the numerator here, not the denominator. We need the numerator to be 0. So you can just kind of multiply that x to the 4th into the 0 and get this. Then I would try to factor out what I can. These terms share a 2 and an x and 7 copies of ln x. So that leaves behind 4 minus ln x, it looks like, if you factor it. So basically, you take each of these factors, 2x and ln x to the 7th and 4 minus ln x. By the 0 factor law, we have to set them each individually equal to 0. So it looks like x is 0 is a critical point. We'll take the 7th root here. So ln x equals 0. I'm talking about taking the 7th root of both sides and getting this. We should do e to the ln x equals e to the 0, letting both sides of the equation become an exponent of an e. These would cancel, and therefore x equals e to the 0, which is 1. Then also, let's subtract 4 here. Negative ln x equals negative 4. Ln x equals 4. Let both sides become the exponent of a base of our choice. So x equals e to the 4th. So it looks like those would be the potential places where we could have horizontal tangents. I've just verified that with Desmos that looks right though. So I typed in the original formula, and the possible critical points are at 0, 1, and e to the 4th. So for 0, that will not work because it's not even part of the domain of the original function. There's an asymptote there, it looks like, and it's just not even going to be defined. If the original function is not defined, the derivative is not defined either, so it can't have a horizontal tangent at 0. 1 looks like a correct solution there. I believe there is a horizontal tangent at x equals 1. The tangent is y equals 0. And then they're saying at x equals e to the 4th, there may be another horizontal tangent. It looks like there is one, yeah. At y equals about 21.9, so that's y equals ln e to the 4th over e to the 4th squared. Right there is a horizontal tangent.